Now that you know how to build a dataset in SPSS, let's look at how to prepare it for analyses. Here I have a sample dataset ready for us. In this dataset, subordinates were asked to assess how much perceived immediacy they felt they had with their supervisor, share their age, how many years they worked for their supervisor, disclose whether or not their supervisor used emoticons when communicating with them, and share their age. Now, what is perceived immediacy? Perceived immediacy is the amount of perceived psychological distance one typically feels with. Here we have a copy of the perceived immediacy measure. You can see what these items look like: cold to warm, close to distant, comforting to uncomforting. So these are the 14 items represented in this questionnaire. If we flip over to variable view, you see that we have a couple of items that have been given particular values. As in our previous example, 1 was assigned to male and 2 was assigned to female for sex. For years worked under that supervisor, 1 is assigned to less than a year of having worked under them, 2 is assigned to 2 to 5 years, and 3 is assigned to greater than 5 years. Last, for whether or not the supervisor uses emoticons when communicating with the subordinate, 1 is yes and 2 is no. One of the first things I like to do before running analyses is actually take a look at my data set. At the very least, I want to look at the maximum and the minimum for each item to make sure there weren't any typos. For example, did I accidentally input that someone was 337 years old, or that someone on a scale of 1 to 7 entered a 77? So to look at your basic descriptive statistics, you go to Analyze, Descriptive Statistics, and Descriptives. I want to look at all of my items, so I can either choose to move them one at a time, I can hit Control A, or I can click on my first item, go down the list as far as I want, hold down Shift and click the last item I would like to look at, and then move them all over. Here in Options, we see the mean, standard deviation, max, and min come selected automatically. You can also choose range, kurtosis, skewness, variance, sum. So we have everything I need, so I'm just going to hit Continue and OK. Now looking at our maximum and minimum, everything looks reasonable, right? On a scale of 1 to 7, no one was marked as having responded less than 1 or higher than 7. Years worked range 1 through 3, as we expect. Use of emoticons 1 through 2. And age 30 through 50. This all makes sense, so it looks good. I feel pretty confident that we won't have any typos in our data. So the second thing we need to do is to prepare our measure to be analyzed. Something that we use in the social sciences is a technique in building measures called reverse coding. Now, reverse coding means that some items are actually written in to be read as backwards of what you're trying to assess. So for example, here we're going from cold to warm, right? How warm your supervisor feels. And on the very next item, we're saying close to distant. Well, if I say a 7 for warm, I'm probably going to say a 1 for distant. When I create a measure to use it, I'm going to use the average of someone's responses to all of these items. So right here, if I don't do anything with the data before analyzing it, item number 1 and number 2 are just going to cancel out, and I'm going to have an average of 4, when really it should indicate more like a 7 or a 1, depending on how I code this, that I feel very close to my supervisor. So what that means is you need to go through a measure when you're using it and identify all items that have been reverse coded. You need to make a decision on which way you want the measure to run, essentially. I like to set up my data set so that the more positive something is, the higher the number is. So I wouldn't want to reverse code number 1 here, because I'd want someone to indicate a 7 if they feel good, if they feel warm. But item 2, that needs to be reverse coded. So does 3, 4, 5, 6, 8, 9, 11, 12, and 14. So how do we do that? In your SPSS file, which as you run analyses and make changes to the data set, a second window will pop up with all of your output. You can just minimize that as you're going. So back in my data set, I need to go to transform, and then I have two options here: recode into the same variables or recode into different variables. The difference is that if I choose recode into same variables, I'm going to actually change the numbers that I have input into the computer. If I recode into different variables, I will keep everything just the same and add a new data column for each item that is reverse coded, which shows that reverse coded value. I like to keep my data sets more simplistic, so I always recode into the same variable, but you have the autonomy to choose however you like to set up your data set. So now I need to select all of those items that need to be reverse coded. After I've selected the items, then I need to click on Old and New Values. This is where I tell the computer how to swap things. Under Old Value, I know that for these items, if someone input a 1, I really need the computer to read that as a 7. If they put in a 2, I need them to read it as a 6. If they put in a 3, I need the computer to read it as a 5. But likewise, a 5 should be a 3, a 6 should be a 2, and a 7 should be a 1. Notice that 4 is not added into this list because 4 is still 4. 4 is neutral no matter which way an item is coded. Now that I've done that, I can click Continue. And I want you to watch right here, item column 2, because this is going to change. My old and new values are set. I'm going to hit OK. Did you notice that change? And now in my output file, it notes that I've recoded these items. Now that I've done the reverse coding, I'd like to make sure that my reliability score is good. When we talked about measurement, we went over the concept of reliability, and I know that you're familiar with this from your statistics course. Reliability is the clarity of the measure, the confidence we have that if we use this measure in a different sample, that it would work just as well. In the social sciences, we don't like to use measures that have reliability scores of less than 0.8 because we imagine those scales actually have some problems and we shouldn't rely on them. So to do this, I'm going to go to Analyze, Scale, Reliability Analysis. I'm going to select all those perceived immediacy items. Now, I just clicked on the first one, held down Shift, and clicked on the last one. You can move them over one at a time. That's no problem. And down here are your different options for making a calculation of reliability. For a long time in the social sciences, we used alpha. You'll see a lot of papers that say alpha equals when they talk about reliability. Alpha is something that we've discovered in the last few years isn't the best option to use, though. Instead, your best option is omega. Alpha and omega are both ways of calculating reliability that use the inter-item correlation matrix. The big difference between alpha and omega is the formula for alpha essentially gives your reliability score extra credit for having more items, whereas omega attenuates for the number of items, so you see a reliability score that didn't get extra credit because it had extra items. Historically, this use of alpha has led to us thinking that a lot of our older measures were a lot better than they actually were because they were built with a huge number of items. These other options down here are also reliability scores that you can use, but along the way, we've learned that they're not the best options. So I suggest, again, going to this model and clicking omega, and then click OK. Now look here, 9.5. That's a really strong reliability score. Now I feel confident that I can start analyzing my data, which we'll talk about in the next video.